Gotta get through this.
It's really bad. Well, because I'm stressing out about it because I haven't started Lab 3 yet because I can't because I don't have my computer now.
Oh, yeah.
So, I mean,
You should be able to log in.
I'm going to try to do it on this one, but...
And I'm about ready to give you more work. Oh,
yeah.
Yep. That's how this course goes.
And
It's a freight train. It does not... Yeah. All right, let's go ahead and get started today. So more about... Today we're really going to go over how OOP, or object-oriented programming, is done in C++. I'm just curious what that's going to be when you're done. Just a hat? A bag. Oh, a bag. Yeah. Nice. Nice. Okay.
It's not a cupcake hat this time.
I don't think I brought my blue one in. I have a blue one that I made my senior year of high school.
Oh, okay.
So now I'm making a red one.
There were 5 people in the
So, yeah, we'll go over OOP and a little bit about pointers, just to clarify some things, and that should give you enough information to really work on your project and the labs today. The lab is really just to help you understand pointers as well as converting your array code from previous lab into an object. So hopefully it won't be too bad. Good morning.
Good morning. Story. Good morning to you. Good morning to you. Data structures is weird and it's annoying to code to.
Didn't quite work out.
What?
Annoying to code to? Oh, well, it gets better.
Okay.
I won't tell you in what way.
That's reassuring.
So objects in C++ do share a lot of similarities with Java, but they're considered more powerful. Well, you can create them on the stack. C++ allows multiple inheritance, so there's no need for the interface keyword because you can just inherit as many times as you want. We don't care. And templates act like generics, except they're a compile time construct, not runtime, so that actually gives it a little more power. We're not going to cover templates too much today. Well, actually, that's all we're going to cover about it. So don't worry about that section too much. But the other two we'll get into. Oh yeah, lastly, remember C++ is compiled to machine code, and while Java is compiled to bytecode. So Java has this virtual machine that it runs under. C++ runs directly on your machine. All right. So I'll try and get through at least a couple of things pretty quickly. Class organization. As with Java, C++ uses public, private, and protected. Morning. The main difference here is in Java, each member is prefixed with the keyword, while in C++ you have sections. Oh, yes, and, well, we'll get to that in a moment. So, let's see. We'll go and make some code. OOP, gvim. What would be a good example? What example do y'all want?
An example of what example?
What object do you want to create real quick?
Circle.
Create
A circle? All right, we'll create a
dragon object.
Ooh, dragon.
All right, dragon.
That would make me happy.
All right, dot. Well, we should do it this way. HPP.
No.
Did I just type? Oh, CD. Whew. I was like, how is gvim not on this machine? All right.
Oh, well, I have that.
So it's a class. So we'll do pound if not defined dragon underscore HPP. Copy pasta. Define it. And if, let me close this real quick and reopen. All right, good. And you do class. You don't need to make your class public in C++. That doesn't make much sense. So class dragon. Now in C++, your class name does not have to share the same thing as your file name. So I could have called it Super Dragon and then have the class Regular Dragon or something, and that's perfectly fine. In Java, the class name had to match the file name. That's not the case in C++. C++ doesn't care. Notice one other difference. I had to put a semicolon at the end of the class. You didn't have to do that in Java. In C++, you're required to. Just keep that in mind. If you get some weird errors that you don't understand why it can't compile, just check to see if you put a semicolon after your class. It gets me all the time. Yes. Oh, it's always the semicolon.
It really is.
INC champion since 1969.
Most common mistake.
So with C++, they use sections and not prefix, so you'll have your private section and you'll have your public section. Wow, that was a weird spelling of public. There we go. So what would be private of the dragon?
Its name, I guess.
All right. string m name. We'll go ahead, have to include that. What else would it have?
Color.
Wings.
Color. We'll make it int color. And then what else? I heard something.
Wings.
Wings.
The ability to breathe fire.
So it has wings, or
It has
Yeah.
wings.
Okay.
Yeah, because there's types that do and there's types that don't. So Boolean.
notice again in C++ it's just called bool and not boolean. And then what was it? Fire attack? Breathe fire?
No, but the ability
Ice.
to breathe fire.
Ice. Not one.
Yeah.
Yeah, I didn't think it
Does
had,
it
like,
breathe
you know-
fire?
Oh, we'll do it. We'll make that an enum, so I'll just call it int breath attack.
That works.
My cat has that as well.
Your cat has that?
The breath attack.
Yeah.
You're like
Well,
holding
that'd be
it,
interesting
and then all of a sudden it
thing.
goes meow, and then it just smells like fish, right in your face,
Meow.
and not just regular fish, like dead rotten fish.
That affected
That just makes me think like
Yeah, exactly.
Less by 10 hit points.
It's super effective. Okay. So inside of public, you don't have to put public again. That's redundant. So we could just have our good old dragon constructor.
Yeah.
And let's see. We'll go ahead and make a int get color. So we'll have standard getters.
How about fighting function?
Get name. Oh, you want a fighting function? Okay. What is it going to fight? Another dragon?
Sure.
All right.
No, a village.
Yeah.
A village?
You're gonna land in a village and then burn
We have
it
a
down.
picture for it and everything.
What's the dragon from The Hobbit?
Smog? No.
Smog.
Yeah.
Yeah, Smog.
Yeah.
We name him Smog.
No, let's name them all to me.
We're not getting the name right now. We're just making the function.
Okay. So I'll just do void fight, and it can be passed another dragon, and I'll pass it by reference. Talk about that in a moment. And
Let's see if we
Huh?
Good, I was just about to ask about that.
somebody's being executed.
let's see. So we have get color, get name, bull has wings.
Hash ring.
Oh, it's the hash
Hash
wings.
wings.
All right. What's another difference right here between C++ and Java?
Wait, what?
Don't write stuff.
What are we not writing?
Everything's in the header.
Well, we have a header, but have I written any code yet?
No.
No, in Java you put your code directly in the class.
Yeah.
In C++ you can do that. It allows you to, but please don't.
Please.
Works for us.
So tab new dragon.cpp will include dragon.hpp. What's magic?
You just did that.
Opening a new tab.
Oh. It's magic. All right. So now we're in our Dragon CPP class, and if we want to create, we want to actually implement the constructor, we need to first basically give a function heading. And you may think that the function heading for the constructor should like this. You would be completely wrong. You actually need to go dragon scope, because you're basically saying, of the dragon scope object class, we're going to implement the dragon function. So notice we have dragon, and then that guy up there. And
Okay, so if you name like the class inside the file something different, you'd have to put the something different in front there, and then
Yes.
do the dragon.
right, so
I was just making
Super
sure.
drink.
if you had another class down here, class village, and over here you could just have
I just meant more along the lines of like how to know which one is first and second.
so by putting everything in the header, that's just declaring what everything's going to be, and then when you implement it, you know later it'll implement it and be able to hook everything up.
So the first dragon is the class, basically, and then the second one is the function.
Okay, so in the header file, you're declaring what the dragon's going to have. You declare.
No.
Go back to
from
CPP. Go to
CPP.
CPP. Like this dragon,
Mm-hmm.
you get from the class, and that's the function. Like,
Yes.
Okay.
That's what we were asking.
Okay. Yeah.
So that was also my question.
So we could have m name equal to unknown. Now let me make sure I still remember how C++ works. So I'm going to try and compile it. Let me make it a .c file. Oh, it worked! Wow.
What? Name unknown.
What? What does it say
He's
there?
not famous yet.
Oh, name unknown. It happens. All right, so we're gonna go and go back.
Start from the bottom, work your way up. Yeah.
What's that?
You gotta start from the bottom, work your way up.
That's right. Tab new. We'll go and make a main.cpp file. We'll include, wow, with capital I. Include dragon.hpp. Int main. Int argc char star argv. So I can create a dragon. What were we call? What was his name?
Depends.
Oh, Alderman.
That wasn't in
That's hard.
Smog.
Smile.
I don't want to do that.
which dragon do you want?
Something unique.
Quick.
Alderman.
Moldeck.
I don't even know how to spell either of those. Go.
AL.
AL.
Network. DU.
DU.
Network.
No. No, we're not taking Alderman.
Come on.
All right, there we
I
go.
did it.
Until they trying to destroy the world.
All right, let's see if the whole thing compiles. Did I type everything correctly? I did. And then I can run it. Oh, wait, you haven't seen that syntax before.
No.
Oh wait.
So what this is literally saying is run this command. If that command succeeds, aka it runs correctly, does not give an error message, run the second command. And you can keep chaining this down. So what I'm literally doing is compile and run, but only run it if it compiled correctly. If it didn't compile it correctly, stop.
Oh, so it's just saying if it compiles, run it.
Yeah.
Got it.
Of course, it's not printing anything out because I don't have anything. But hey, look, I created a dragon object. Okay, real quick, what's the difference here between C++ and Java? I created a dragon object. Where does that object reside?
It's that.
Stack. Did you do that in Java?
Nope, it had to be on the heap.
Yep, has to be on the heap. What's a nice... Well, no, we'll get to that in a minute. All right. So if we were in here, we should be able to see out... Let's see, all has wings. And then we'll print out dot has wings. So is this going to compile?
I think you forgot some, like the insertion operator on the left.
Oh, I did. Good job. So that was the first error. Anyone else?
You also
I think it might, but it's going to give you
Yeah, you
something
spelled
weird.
Alderman.
But I misspelled it correctly in both.
Not there.
No,
In the
Aldoon.
quotations.
Aldoon.
All done.
StarCraft.
It's from Skyrim.
Sure, whatever. All right. Anything else? There's going to be an error.
Yeah, because you haven't exactly defined whether or not doing sketch.
Right. Well, if I try and compile it, error. Oh, cout's not a member of. Okay, so that's the first error.
Yeah, that's the first one I have to do.
So we need to include the IO stream,
That might be helpful.
and then under find a reference to dragon has wings. What does that mean?
Haven't defined
haven't
whether
defined
he has
it.
wings.
Oh, I haven't defined that function yet. Silly me.
It's okay. We got you.
So bool dragon has wings.
Hash wings.
Attachments.
I really want to hash those wings. That's all I want to do.
Every time you do that, all I can think of is this the hash swinging slash.
All right, has wings. Okay. So now it's a.
What?
Yeah, it runs. Well, this time it's 0.
Hey.
We never said if it has wings. You probably should give it a better constructor. What do you think? Yeah, so we'll have name and color. Bool has wings and int. Oops. Breath attack. The break attack.
I mean, that's what I
All right, so we'll have m name equals name, m color equals color, m has wings equals has wings, and m breath attack. Yeah. You can keep that going. I mean, I was just typing away. Jam while I was typing. That would have been perfectly okay.
Jam.
Oh, it's advertisement. All right, so we have that constructor. So let's maybe give this one something better. What was the next one? I already forgot it. Color has wings. All right, so it's color. We'll make it 2. We'll make it true that it has wings, and then its breath attack will be a 500. No, wait, 9,000. There we go.
No, 9001.
All the way did that.
All right. So now if we run it, now it has wings. All right.
Yay.
How come it says 1? Oh, true.
Because that's true in C++. Java would actually convert it to true and false. In C++, bool is just an integer. Because in reality, that's all Boolean is. Java just tries to make it type safe. Which is good of it too. But so we can call get name, and if we try and run this, what's going to happen? Y'all are good at this.
Hey, from like watching you, we pick up on syntax errors.
This
a
is
lot
great.
quicker.
I have taught y'all well. It's all me about that, indeed. All right, so if I try and run this, what do you think is going to happen?
All the week name, all the week.
Oh,
Yeah,
yeah, we never defined name. No,
Yeah. Oh yeah, true. We did not.
we never defined it.
Okay. We got to do
Next.
that.
We're going to get, it's going to happen all the time.
Why don't you just include the STD at the top?
For some reason, part of me just cannot include STDs in my program. I just can't do it.
Yeah, no, yeah. You're
I just cannot do it.
Back in your program.
They can't have,
I just
gonorrhea.
can't do it.
You can't put like gonorrhea, syphilis,
It's just I just can't do it. I'm sorry. All right, so now it runs.
I thought there was going to be a better answer than that. That's the one.
I just can't do it. I mean, you literally type using and then STD up top. I can't do it. I just can't do it.
Using name, space.
Right. We're just gonna leave that be. All right. And then we have Aldrine's name. All right. All right. So let's say we have the header file and we want to include the fight. Good morning. Don't worry about it. Watch the video.
Watch the video later.
All right, so if we want to include the fight function over here, this is what it looks like to begin with, but what do I need to change?
You have to add dragon
In front of,
fight.
and what needs to exist between the dragon and the fight? Well, that was weird. Let's try that again.
Scope resolution.
Yeah, scope. There we go. Okay. Now, what is this crazy ampersand thing? All right.
That's a reference.
It's a reference. Did y'all learn references in C++? Oh, y'all did?
Yeah.
Oh, great.
Well, like.
All right. When the ampersand symbol is used in a function, I'll say argument, comma, it is passing the argument.
Ampersand? Or whatever.
Is that what that is?
I don't know. I can't spell it.
By
I can't say it.
I
reference.
think it's ampersand.
It's
Amp.
Amp.
Ampersand.
Okay, ampersand.
I don't think argument has an E in it right there. I could be wrong. This means we do not copy the value of,
The veil.
thank you, of the argument, but instead reference the,
So you don't make another object, you just reference the object.
yeah, instead reference the
Good, because that takes up
parameter.
a lot of memory.
You got it. I'm glad you all have that because that is awesome. All right.
Makes it easier for you.
Yes.
She's stretched crocheting.
It's just. All right. So what's another dragon?
Parson X.
Let's go.
What was yours?
What was yours?
Moldeck?
Moldec. M-U.
No, it's MOLDEC.
Wait, DEC or VEC?
Oh, it's
All right, Moldeck. Color, we'll make him 5.
You just made it up.
Can fly?
What?
Fly?
Yes.
And what is its breath attack?
6,370.
No, it's fine. So we're down here, and we can do Moldeck's breath attack.
What is fog represent? Or like, what is the color?
What's
That's the color.
Oh, okay.
Yeah, what do the colors represent on these? Like,
Oh, by the way, are y'all able to see that from back there? Or do I need to increase? You're good?
Yeah, you might want to increase the font. We're good.
There.
We haven't really defined what those numbers mean for the color.
No, we don't care. So,
It doesn't matter with dragons. Their color is important.
well, you know, I'm just trying to keep a simple example here, so.
Simple example. Do you remember our Pokemon thing from last
Oh, that was-
episode?
That was so in-depth.
I love how
There was
Sue was like, I have no idea what's happening anymore. Can we just do something else?
Just go with
Just
it.
gotta love the imagination in this classroom.
Yeah. So we need get breath attack. All right. So this will print out the breath attacks of, was it Moldeck? Ooh, that was spelled incorrectly. And
Modek.
Alduin. All right. Oh, I misspelled something. Has no member get breath attack. Oh no.
Oh, we didn't do that.
If we need another dragon, can we name it your cat's name?
What is my cat's name?
What?
I just call it Shadow Cat because it's black. So
It actually has a name.
well, I mean, it's dark, and you're like, wait a minute, that shadow is darker than it should be. And then all of a sudden, these two eyes open up. You're like, oh.
Oh. No,
How long
my
have
brother's
you had
cat
this cat?
can't do that around the house.
I don't know, a couple
Bell
years.
around his neck.
Why do you even have a cat?
My wife loves cats,
Yes.
and therefore I do as well.
That's a good
Happy life, happy life. Have you never heard this saying?
You never have? It's a really important saying. Make sure whoever you marry understands it, okay?
Yes.
All right? All right, good.
If not, you have to teach them.
Yeah, well,
I'll slap him in the face with a book and say, learn it.
so get breath attack, we'll return the breath attack. All right. So, breath attack of Moldeck and Alduin. All right. We probably should-
Moldek's gonna die a lot fast.
We should probably put a Boolean, bull is dead.
More armor, more stuff.
More health and more just natural.
All right, so is dead.
body.
We'll go over here and we'll have is dead.
Dead.
Is dead.
Wait, we have to like determine their health too.
No, we're not going to go that
A
complicated.
little, like,
No, we're just going to compare the two breath attacks. Let me make sure I typed that incorrectly. I sure did. And then we'll go over here and copy all. We'll go is alive. I never put a getter on that. Wow, all these getters. Who does all this? Bull get or is alive.
Bull, get alive.
Get alive. No, just is alive.
We'll get alive. Does that mean you resurrect it?
Say get alive.
Get alive. Is alive.
Get?
Return not is dead. All right.
Wait, did you just say get as in get help?
No, I was saying get as in get a life.
All right, make sure that compiled correctly. Woot. Not quite. M is dead. Did I misspell something? M is dead. M is dead.
Did I
What?
say it?
Gluten. Guess I should spell
That's
dragon.
it.
All right. So let's go back over here, and that is alive for Alden, and then Moldeck.
I really don't like that L, do you?
No, I don't. I typed it correctly that time, but I made it capital for whatever reason.
is it the proper name?
Is alive 0.
Both dead.
Well, actually, that's true. Because, what was it? Yeah. True is 0, everything else is false.
Oh, true is 0?
Yes.
Okay, so they're both alive.
Yeah, what?
Right.
Yeah, here we go.
Yeah.
Yeah, so we'll do
0. Everything else is false. Okay. I gotta remember that.
true.
I have a question.
Yes.
Why do you throw an M in front of all your variable names?
Because he likes to.
Yeah, it's just something he does.
So true. Oh, true is 1. Uh-oh, we're in trouble. Okay.
It's just how he likes to separate his variables.
Oh, I see.
Do it. See,
Alright.
up there, you put it at false.
Yeah, I did do that false.
I said that.
I knew the 0.
Thank you. All right, why do I put m in front of my variables? Member variables, I start with m. That way you know it's the member of the class. That's just a convention that I have decided to adopt. I learned it at Google. I like it.
Okay.
It makes things simpler.
What?
Simple.
What did you learn at Google,
Overrated.
sir?
Put the m in front of all the member variables of the class. I put s if they're static. M, regular member variable. S if it's a static member variable.
So it is your
So I think it makes it easier to read. And I like it. Okay, so true is 1. We fixed that problem. So we'll go ahead and have Alduin.fight Moldek. And then we'll print out who's alive afterwards. So basically, let's see if fight right now doesn't do anything, but we'll have if dragon dot. Now we could do get breath, but since we're part of the class, we can just we can do m breath attack is greater than my breath attack. If the dragon being passed in is greater than mine, then I'm dead.
Else instant.
Else if, I would actually say, else if m breath attack is greater than the dragon being passed in dot m breath attack, then that dragon is dead.
What if they're equal?
But if they're equal, nothing happens.
Okay.
Already both died.
We'll just make it equal. So then it looks like Moldek died.
Question. So M breath attack, which dragon is that referencing? I know-
M breath attack, so that's referencing the current dragon that's of the class. I mean, I could do this dot just like in Java, if that makes it clear. So the current executing object.
Story?
Yep.
Yeah.
Story.
So, I left my house at 7:30, and as I was going, everybody miraculously forgot how to drive.
Oh, you mean they kept confusing the gas pedal and the brake pedal
Yes.
for the same thing and didn't realize? Yeah. Okay.
That sounds like Floridians.
Yeah.
Yeah. Oh my goodness. Second you get into Florida, well, who cares about the speed limit? And then, yeah. Anyways, so the M breath attack, that's the current executing object. So, for example, I'm calling Alduin.fight. So in this case, M breath attack, aka this dot M breath attack, is Alduin, while the dragon being passed in is Moldek. So that would check if Moldek.M breath attack is greater than Alduin's breath attack. Okay? And then down here, it's if Alduin's breath attack is greater than the passed in dragon, which was Moldek. All right.
That's relevant.
All right. Any questions? Hopefully, this shows you a couple of differences between Java and C++. At least this really is the basics, but it gets far more complicated in a minute. But any questions on this one? Great. Oh yes, and Friends. So,
Friends like the TV show?
all right.
Friends?
So if I was inside a village and I had a public, let's see, is attack, and we'll pass it a dragon by reference, or I'll just have attack. Actually, we'll go over here and make it, that'll make more sense over here. Attack, and we'll pass it a village. Now, first off, there's an error right now. Does anyone see what it is?
To be a boy, you have to
That's good. That's the first error.
You need to declare village as a object.
Village is a class down here, so it's been declared.
Class. Therefore, it didn't know that.
Let's see, it should give me an error. Yep. Village has not been declared.
Yeah, so it had to be before, right?
Yeah. Village has got to come before. Java would automatically fix this for you. C++ does not. All right, so we're in here. We'll take this. Go dragon, attack. And we'll just pretend that the village has some private member variable. I don't know, private.
Population.
Good. Pop. Population. All right. So, should I be able to go village.m population equals 0 right here?
I doubt it, 'cause it's not defined. It's defined in other place.
Well, m population is part of village.
Maybe.
It's private, right? Because the population is private of village. All right, and I completely forgot the syntax for this, and the reason I did is because you're never supposed to do this. But we'll go ahead and Google it real quick. Or maybe we won't be able to. Oh no, there we go.
Let's just tell them.
Friendship and inheritance.
Friendship and inheritance. Wow, it sounds like somebody passed away.
We'll just open all these, and maybe one of them will just tell me. Wow, the internets are slow. Friend. Okay, so it looks like I just go inside of the village. Do I? That doesn't make any sense. Class Y, friend, non-member, blah, 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 will have access to Y's private members. It will? Where's friend? Friend void set. Where is it? The next. That's not it.
Not a good one.
Come on. No, we don't want to.
Oh, something else stopped.
All right. So we go. Really? That doesn't make any sense. That doesn't make sense.
The other one's finished loading.
Oh, wow. Okay. So in order to make this work, oh my goodness, class dragon, semicolon, and then we really go in here and type friend class, okay, friend class dragon. I really don't think this is going to work, but it may. Oh, it did. Okay. So, why did I have to do it this way?
So the dragon can
Don't ever do this. All right. So I had to declare the class dragon first, because if I didn't, it would, okay, maybe it'll work. All right, so we don't need to do that. So I have village. I tell it its friend class is dragon, which now means dragon can access the private parts of village. Private members of village.
There's a reason they're private.
Right. Okay. Why is this bad?
Because Dr. West says it's bad.
Because encapsulation.
It breaks encapsulation. C++ allows you to do this because C++ don't care. But it breaks encapsulation. In other words, when it comes to C++, friends are bad.
Okay.
Don't have friends in C++. There are no friends, all right?
Yeah, it'd be like me and have no fun.
All right. So inheritance. I don't like doing inheritance, so I'm just going to talk about it and then not do it.
That works. I think we understand.
Features of class can be defined and based on another class. You went through this hopefully a lot in OOP, and you're probably hopefully tired of it. Good. I'm glad, because I am too. Methods and attributes are inherited. So in Java, public class A extends B, but in C++ you put a colon instead of the extends. Everyone got that?
Colon instead of extends.
You got it.
A colon instead of what?
Extends. Here, let me get the pointer. All right. See how it goes public class A? Well, C++ we don't need public. So class A, You have extends, but instead in C++ you have a colon public B.
Oh, that makes life so much easier.
Less typing.
Multiple inheritance is possible in C++. So you can do public B, comma, public C, comma, public D, comma, public E, etc., etc.
Why do we use the word public instead of just class?
So it depends on what parts you want to inherit from B. You inherit it publicly, privately, etc., etc. Down the OP hierarchy you want to inherit the member.
Then you only inherit the public part of it and not necessarily.
No, you inherit it and it's public, meaning that everything down below it can also access as well. Because if you have D also inherit from A, if A inherited D publicly, D would have access to B.
Okay.
Do you want that?
It depends on your inheritance hierarchy that you have chosen. That's why I don't like it. But it depends, thank you. In Java, you may implement several interfaces. C++ doesn't have interfaces because it supports multiple inheritance, so we don't need interfaces. Forget it. Parametric polymorphism.
We'll get to it later.
This was generics inside of Java. It's templates in C++. We'll get to it later. It's actually, it can be complicated.
Sounds good to me.
Pointers. In Java, a pointer was called a reference to an object. So you have string str equals new string hello. In C++, a pointer stores the memory location of something else. So for objects, string knows the star in front of str equals new string hello. All right. Did we do this a little last time?
Yeah, we kind of went over it.
Okay.
It was the difference between stacking and heat for the code.
All right. So we were in here. We go dragon. What's the third dragon?
Charizard.
Shadowcat.
Charizard's not a dragon.
Orphan
Charizard. Is that right?
No, Charizard's not a dragon.
Not a dragon, it's a biotype.
Yeah.
You've got to be kidding me. Really? He looks just like a
It's
dragon.
not.
Shadowcat.
It's not.
Shadowcat's not a dragon.
Orphan
Shadow. Just do it shadow.
Shadow. All right. Shadow. What's new? Dragon. Shadow.
Isn't Shadow a hedgehog?
I don't know.
Yeah.
It's also his cat.
Does he have wings? Oh, it's my. Oh, so she does not have wings. And her breath attack,
It's terrible.
Two.
it's either 2 or 2 billion. I can't decide which. We'll go with 2.
Depends. Do you want to type a bunch of zeros?
All right. So, what's the difference? What is
2.
the
It's enough to be annoying.
difference
But not kill you.
between this and the above all doing and mold down?
I really don't like that number.
Yeah, whatever.
Yeah, a little bit.
So, what's the difference?
Okay.
It's a pointer.
So shadow is being declared on the is being put on allocated onto the heap, while Alduin and Moldek are on the stack.
Correct. Correct. All right. Now,
Which is better.
sure. Which is better? I'm glad you asked that question.
It depends.
Okay. Man, y'all are doing great. Y'all know exactly how this goes. Because that's what your boss is going to say. Which is better? And then you just need to say, it depends.
Depends how much time and how much money.
How much? Oh, that's awesome. That's awesome.
You raised these Padawans well.
Yes. In my undergrad, the first programming class was called Programming Analysis and Design. And it had 2 sections, 1 and 2. So it literally was Pad 1, Programming Analysis and Design 1.
Great.
It was awesome. Okay, Pad 1.
CFC.
No, that was Trinity University.
Oh, Trinity?
All right, so shadow is a variable on the stack that points to a dragon object, and then we allocate the dragon object on the heap, and we return a pointer to it or the memory address and store it inside of shadow. Shadow. So if we were to print out Shadow's breath attack, is this syntax correct?
No, it is not correct.
Why is it not correct?
Since it's a pointer, you need to dereference it.
Right. So you can't just call it on the pointer. Luckily, this happens so much that C++ will say, maybe you meant the arrow? So you could do the arrow, which automatically dereferences and calls it, and you're good to go. Let me just show you what's actually happening. Isn't that nice of the compiler?
It's so nice.
That is the same exact, whoa, that was weird. Same exact syntax as this. Dereference, then called the dot breath. It does the same exact thing. The arrow is just a shorthand, and most people use the arrow.
Because it looks cool.
It does look cool, and it's a lot easier to read.
You mean parentheses aren't easy to read?
I'm not saying the parentheses are hard to read. I'm just saying the arrow is easier. Okay, any other questions about that? All right.
Next.
Better explanation. So in Java, a pointer only exists to objects, and C++, a pointer may point to anything. You have to keep that in mind. It can point to anything. What does that mean?
It can point to sadness.
It can point to sadness. It can also point to happiness.
It can point to neutralness.
Neutral. So which one's easier?
It depends.
C++.
Well, it's simple, right?
No, it's not. You're mechanical.
Mechanical?
Did I say mechanical? Maniacal? I put a C in it. Oh, I've killed myself. Okay. We'll see what that means.
Plus gives you 1 life.
Yep. All right, constructor. Oh, wait, we've talked about constructors. You have the constructor, the default constructor, the user-defined constructor. Luckily, Java and C++ behave the same exact way. Whew. And I already gave you examples over here. Where are the constructors? Right there. Okay. Right here? No, okay, right here. So constructor. So those are the 2 constructors. We're done. All right.
Don't forget your constructor.
Yeah, don't forget that.
Sadness will occur.
In Java, arrays are actually objects that store the length and other information. In C++, an array is a sequence of data. Nothing else is stored. So right here, you do int x of 20 and button b of 20, which are valid declarations in C++, but not in Java. Why?
Yeah, I agree with the object.
Yeah.
You have to do new and
Yeah, because it has to be allocated on the heap. Therefore, you have to put new. But what is this doing in C++?
looking at on the stack.
The stack. Why would that be useful on the stack?
Because it's a fixed amount of memory.
In memory.
No?
So no, you're right. So in C++, you have to deallocate your memory, right?
The stack is automatically deallocated.
Right. So if it's on the stack, it automatically deallocates it for you. You don't have to write delete at the end of your function. It just does it. All right, let's see. Pointers. There's a close relationship between pointers and arrays. So instead of int x20, you can issue int star x and then x equals new int 20 to allow for dynamic allocation. So let's go ahead and close this. Let's see. Back to class code. Oh, I already have a pointers directory? What have I done here?
What?
Apparently we already did some of this. Oh, that's beautiful. Oh, yes, we did do this. Okay, great. Evil pointer. So we've already gone through a couple of these things, but let's go and extend this, and I'll do the array pointer function. Array pointer. So if I call int star x, what is the value of x? What is the value of x?
It's can be anything.
Anything. So
That randomness.
undefined. X equals new int of 20.
Why wouldn't you just do that on the same line?
Because I want to show you that they are 2 separate steps. So allocate, what does this do? Allocate 20 integers on the heap.
On the head.
On the head. All right. And I think we did some of this where you could do x plus 3 dereference equals 10, and then you could also do cout x sub 3 equals, and then x sub 3. Just to show you that, hey, look, these are two ways to access the same thing. So I'm going to g++ pointers.cpp, and if it compiles, run it. Oh, x sub 3 equals 10. You could also do x sub 4 equals 20. Now we'll have x sub 4, and print that back out. And now it's 20. So we did go through that. Any questions on this?
What was the difference between dereferencing it and just doing the x sub 4 on this one?
Okay. This is a shorthand of the above, except with index 4. The subscripts is a shorthand of above. What is actually happening is what you see above. That is what the compiler actually generates.
Okay.
But they give you a shorthand for it.
And is 10 the value stored at that index?
Stored at that location. Because go to X, jump over 3 slots, 3 integers, dereference it, go to that memory location, store 10 there.
So the one below it automatically dereferences?
So what this does, it's the same thing up there. Take X, jump over 4 integer spaces, dereference it, store 20 in that location.
So that's the thing being stored.
20 is being stored in that location because you're dereferencing the pointer.
Okay.
All right. How are we doing?
Good.
Good. All right.
Do you hear me now?
I can hear you now. All right. Oh, yes. So if we were to Valgrind this,
Oh, yeah.
would bad things happen?
Same as will occur.
Cool.
Definitely lost 80 bytes. We forgot to delete X. Oh, wait, we should probably compile it first.
It might be slightly more.
Oh, okay, there we go. Total heap usage. 1 allocation, 1 free. 80 bytes allocated. You're good to go. No leaks are possible.
Yay.
Yep.
That's happiness, not sadness.
That's happiness. Now, if I were up here and I did double
Don't forget to delete.
100, do I need to delete that?
No, because it's on the stack.
It's on the stack. So I'll compile it, run under Valgrind. You're fine because you never allocated in the heap. It was allocated on the stack. Magic. All right, constructors. Java, the constructor is invoked through the new keyword. And C++ constructor is called upon variable declaration or explicitly through with pointers or in other situations. Well, that's kind of complicated. But really, you just need to understand that going back to our dragon example, I really need to set the font to default to 12 somehow. Notice that here, the constructor was being called. It wasn't, we didn't do new, but it was being called when the dragon object is allocated on the stack. And then down here, the constructor is called when the dragon object is allocated on the heap. So it happens during creation or allocation. Okay, got it? What do we have here? Special method, oh, a destructor. Oh, that did not come out on the slides at all. All right. Let's see what we got. GVim. Let's say, actually, G++. Do we have any issues here? Let's find out. And then if we try and Valgrind a.out, do we have any memory problems? We do. Indirectly lost. Wow. All right, what did we do wrong? Yeah, we probably did. Probably. What did you forget to delete?
Shadow.
Yeah, we gotta delete shadow. Goodbye, shadow.
Shadow.
Notice that since I'm not deleting an array, I'm just deleting one object, I don't need to put the solid curly brackets. Notice back with the array, I had to put the the solid brackets, because I'm deleting an entire array. All right, let's see if that fixed the problem. Probably did.
Oh,
It did.
that's where the issue is.
Okay. Now, let's take this to the next level. Dragon.cpp, and then let's open up dragon.hpp. All right, what would be a good thing here? Maybe I can make a dragon. It would have a dragon, and we'll just call it the child. All right. And I'll just make a little function, void set child. It needs to be passed to dragon. Yeah, this will be great. Okay. Or actually, let's do it differently. Void create child. And it needs all of this. So I'm going to copy and paste this down.
Oh. I can do that.
YY.
Why?
YYP.
Oh.
DD. Delete the line. Alright, so create a child. So we'll go inside the CPP file. We'll put it up here. Create child, it needs to be part of Dragon. Alright, we'll have m child equals new dragon, passing in the name, the color has wings, and then the breath attack. Okay, that looks great. So if I were over in my main function and I decided that inside of shadow we wanted to create a child mini shadow.
No, chibi.
Chibi? Chibi?
Yeah.
Does Chibi have, what color is Chibi?
White.
1. Alright, good. And then does Chibi have wings?
Yes.
Okay.
Sure, why not?
And the breath attack?
5.
5.
Oh.
Slightly stronger.
Alright, so let's make sure that actually compiles and runs. Looks like we missed something. Create child. Oh, because since shadow is a pointer, we have to use the dash arrow to call the function. And there we go. Do you think there is a memory issue?
Only one way to find out.
Potentially.
No, because you deleted shadow.
Ah, I did delete shadow.
Isn't chibi is
Shouldn't you delete child too?
Yeah, but we delete the shadow, but that doesn't mean that it's going to delete the child that is part of shadow. It's only deleting the shadow object. It's not jumping into your pointers and deleting the children. So,
I hope you don't delete children.
wow, that was kind of sad. All right, maybe I should come up with a better example. All right, so in C++, this does not exist in Java. You have what's called a destructor. A destructor is tilde, the class name, open close parentheses semicolon. That is the function heading. There is no, you don't pass parameters to the destructor. It's just tilde, the class name. So you can go,
Label that as the destructor.
thank you. Let me get this up and then I'll destructor called when the object is deallocated, or I'm sorry, is going to be deallocated because it hasn't happened yet. Let me copy and paste that over here. All right, so if we're in here, what do we need to delete?
You need to delete the child.
All right. Okay. So if I compile and run this, what do you think is going to happen? Well, this is really a really tricky situation.
You cannot delete the child, and then it will delete itself,
Right. So the destructor would delete the child and then delete itself.
even though you didn't tell it to delete itself. It will still do it anyway.
Well, that's no. We told it to.
No, we told
So what this command over here does, delete shadow, says, all right, you need to delete shadow. And it goes, okay, hold on. Before I delete shadow, I'm going to call the dragon destructor and ask if there's anything that needs to be deleted first before I delete my object. And
So whenever you have something that points like an object that points to something else,
Right.
you have to make sure to get a destructor so it'll delete everything.
you got it.
So wait, when you call the delete command on an object, first it calls the deconstructor and then it deletes it?
Yes.
So what if you just call it a deconstructor? Will that only delete like will that only
I have
delete the-
never ever tried to do that. Let me see if C++
not delete the object?
Let me see if C++ would allow me to do that. I don't even know what that would look like. Like that? Does that even make sense? Wow, it took it. Yeah, so you can manually call the destructor. There's no need, because when you call delete, it calls the destructor. But I did a double delete there, so it's a bit of a segmentation fault. But all right, so yeah, that's what's happening. We're going to go and delete shadow. Before it gets deleted, we call the destructor, which, wow, that was weird. Okay, it's going to delete the child. So the child gets deleted first, and then the object gets deleted. All right.
That also just delete the object too, even if you're not necessarily using the delete keyword.
Wait, say that again?
Okay, so when you call the delete keyword, you're calling the destructor, and then you're also deleting the object itself.
Right.
But say you just only call the destructor and don't call the
Delete?
delete function.
Oh, yeah, like we did up here.
Yeah. So
Yeah.
would that also do the same thing, or will it only delete the
So
child and not the
it
object?
would technically just delete the child, although it looks like it causes a segmentation fault. So don't ever call the destructor.
Okay.
Don't ever do that. Well, actually, it caused a segmentation fault for a completely different reason.
What's that reason?
Oh, yes. What is that reason? Remember, I said the destructor is called whenever the object is deallocated. What objects do we have? How many objects do we have?
Shadow, Moldeck, and Alden.
Yes. We have 3 objects here. So all doing
Oh, it
Moldeck,
doesn't know which one knows.
do they have children?
No.
No. But we're still trying to delete a pointer.
It doesn't know what to delete.
Right. But should it even delete anything?
You're telling it to.
Well, no. Should Alduin and Moldeck delete anything in this situation?
No.
No. Why not?
They're on the stack.
They're on the stack. But semantically, why should they not?
They don't have children.
They don't have children. Let me show you the way to do this. Make sure in your constructor, if you have a pointer to something and you don't allocate it, make sure you set it to null. Always set it to null.
Why?
That way you know that it's not pointing to anything. Because remember, in C++, when you create a variable, it's whatever's there. It may be 0, it may be 1,000, it may be random number. So you need to make sure it's null. The reason for that is when you're down here in the destructor, you can basically say if mChild does not equal null, delete, then you may delete the child. And of course you want to set mChild equal to null afterwards. So if we do have a child, delete it.
Would you switch the two? Because then you're allocating memory to one.
This way?
Yeah.
Well, you set it to null and then you try and delete null. That's not going to make any sense. You're trying to delete the kernel?
Yeah.
That would be bad. And if I recall correctly, null is not built in. Oh, it is built in. Great. So you don't need to do that. Notice also there was no segmentation fault. Do y'all see what I did there? Make sure y'all do that. If you have a pointer, set it to null or set it to something else. Just make sure it's been initialized.
Don't have randomness.
All right, let's see if Valgrind, if that fixed all our memory problems. Oh, look. 6 allocate, 6 freeze, we're good to go. All right. That fixed the rest of the memory issues. Oh, magic. All right, you understand why you need to call the destructor? All right. Good.
Status will occur if you do not.
If you do not. Yes. Okay. We'll get more into this later, but be aware that C++ is so powerful that you may redefine what equal does.
What?
Whoa. You're kidding me, right?
Nope. You may redefine what equal does. You may redefine what plus does. You may
Why?
redefine because it's C++. And we just want to let you do whatever you want.
Now, if you
I don't like that.
Now, if you
I need
redefined
boundaries.
it, if you redefined it, would it only redefine it for that program?
Yes.
Okay. Don't break your whole machine.
Imagine if you can redefine it in the kernel.
Oh no.
That'll be fun.
So,
Someone else tries to.
so you could do A equals B. Normally, if you're over here, you have a shadow, and then you have dragon, star, I'll call it the shadow with the capital S, equals shadow. What's happening? If I create a shadow, we'll call it, let's do this, shadow alias. That way you know exactly what I'm doing. Create a variable called shadow alias on the stack that's going to point to a dragon object, and then I set it equal to shadow. What does that do afterwards? Because it's legal syntax, we're good to go.
Isn't it just a pointer to shadow?
Yes. It's going to copy the memory location of shadow. Remember, shadow itself was a pointer, and copy into shadow. So
You're using a pointer to point to a pointer.
now using a pointer to point to the same thing. So now shadow alias also points to shadow.
So 2 pointers do the same thing.
Yes.
Okay.
Do I need to delete the shadow alias? Hold on. In this situation, do I need to?
No, because shadow.
Already being deallocated. So I can delete shadow or shadow alias, and I'm okay. No memory problems. All right. C++, sorry, could redefine what this equal does. You could redefine, this is called a shallow copy, because you are just copying the memory location of shadow into the shadow alias. Since C++ can redefine what equal does, you could redefine the situation such that it would create a new dragon object and copy all the contents of shadow into that new dragon object, and then have the shadow alias now point to a new dragon object.
That's a lot in one breath.
That's called a deep copy, because you're going into the object and copying everything inside of it.
Now that would be useful for that array lab we did last semester.
What is the array lab due next week?
Yeah, Tuesday.
Tuesday?
All right. So methods define behavior, static methods versus instance methods. Static methods in C++ are going to behave the same way as they do in Java. Same thing about the static member variables. AKA, there can be only one, or there is only one. Method overloading, 2 methods of the same name with different signatures. Y'all are used to that. C++ supports it as well. Overriding, same signatures across different classes, subclass and superclass. Y'all are used to this with inheritance. We're not going to do this too much, but it works the same way in Java as it does in C++. Yes, so you could overload the operator. For example, if you had a class matrix and you did matrix operator plus matrix M, and then you had C, A, and B all be a matrix, you could literally do C equals A plus B, and it'll run the code inside of this function instead of whatever else plus would do. Functionally equivalent to C equals A dot operator plus passing in B. What do y'all think of this?
I don't know if I like that.
Why would you not like that?
Weird.
Weird?
Just another tool in your arsenal to get the job done.
Okay, yep, that's true.
On the surface, it seems like it's too much power. Power.
I'm just a bit confused.
But then you realize it's not, as dangerous when you know what you're doing.
It's the issue if you know what you're doing.
Yeah,
Right.
that's key for you to do.
If you redefine plus to do subtraction, are other programmers going to be happy?
No.
No.
That's
So,
a surefire way to piss them off.
so if you accidentally overload your operator to do something that's not intuitive, which happens, then yes, you're really just annoying people. So C++ wants to give you all the power, so it allows you to do this. Java specifically chose not to allow this because they wanted to enforce consistency in all of its operators.
That makes sense.
There'll be a little bit more about this later. I'm just trying to tell you why C++ gives you so much. All right, method binding. This works the same way in Java as it does in C++, but you probably have forgotten exactly what I'm talking about, which is perfectly fine. So teacher be a subclass of employee, aka teacher inherits from employee. And suppose promote is a method defined in both classes. So if you have employee E equals new teacher, and E equals new teacher, and C, when you call E dot promote, which promote method is being called? The teacher's promote or the employee promote?
Hey, wait, which one was first?
Look at the code. So, okay, teacher inherits from employee. So teacher is a subclass of employee. You make employee E, or let's do this, employee star E, so E is going to point to an employee object. E equals new teacher. Since teacher inherited from employee, this is perfectly fine, so E now points to teacher. When you call E dot promote, is it calling the teacher's promote function or the employee's promote function? Right, the teacher's promote function, because that's how it binds it. Right, it finds the first one and then calls it. All right, just reminder, that happens the same way in C++ as it does in Java.
Isn't that kind of like overloading function?
Yeah, in a way. But it's method binding because it's binding the method to your object when you create it. Yeah. All right, static versus dynamic. Employees promotes called. Oh wait, no, in C++. I lied? Oh, I lied. Really? Oh, C++. No wonder I despise you. So it's the other way around. Really? I'm going to have to run this. Ah, C++. Apparently in C++, the employees promote's called, and in Java, the teacher's promote is called. Oh, that's sad. Oh, well. We're not going to do this because that's just evil. All right, there are many more features to object-oriented programming. I didn't want to get to them all because we're going to run out of time, and you need to have time to do your labs. Overview, pointers real quick. I want to go through a couple more evil things. Pointer can point to anything, well, at least anything that's pointable.
What is not pointable?
I can't write a program that points to me. But you can point to anything inside the computer. So int A, declare variable A that stores the memory address of where an integer resides. Int B equals 32. A equals ampersand B. The ampersand bit symbol calculates the memory address of the following variable. Notice that the two differences here. What was the other time you used ampersand?
Reference.
Reference. So in a function, the ampersand means you're passing by reference. When you use it outside a function, you're calculating the memory address of the following variable. So A is going to store the memory address of B. So when you dereference A and set 64 to it, and now means A is pointing to B, and B now has the value 64. Redo it again. A is going to be a pointer to an integer. B equals 32 on the stack. A is now going to point to B, so it stores the memory address of B. Dereference A, go to where A is pointing, store 64. That also happens to be B, so therefore B now is equal to 64, because when you dereferenced A to the memory location of B, and then you stored 64 there. Okay? You better get this clear. If there's any problem, please tell me, because it's only going to get worse if this is any way confusing.
What chapter of the textbook would be good to read about this stuff?
That's a great question. It doesn't really cover it too well. Just Google pointers.
Google's your friend.
Yeah, you got to understand pointer. Now notice this is a stack pointer because B is on the stack and A is going to point to B, which is on the stack. So that's a stack pointer. A heap pointer is what you're used to with new. Create a new int on the heap and have A point to it. So this reads literally create a variable A on the stack that will store the memory address of an integer. Next allocate an int in memory, namely the heap, and store the memory address of that int in A. That is exactly what the computer is doing. You can manipulate the new int just like before, although since the integer is on the heap, you must deallocate with delete A. All right, good. Array arithmetic. Excuse me. We went through this a little. So int array of 100, is that array on the stack or on the heap? So it's on stack. So int A is pointing to the array, which is on the stack. So A is now pointing to something on the stack. It's now a stack pointer. First line creates an array of 100 integers on the stack. Second line creates a pointer to the array. Notice that we didn't use the ampersand in this situation. That's because when you do an array with solid brackets, you're actually declaring array as a pointer. Array ARY is actually a pointer. This is just another shorthand for declaring a pointer. Okay? Just, it's a pointer now because you use the solid brackets afterwards. It's a pointer. So A plus 10 equals 50 is the same as array sub 10 equals 50. They do the exact same thing. Okay? All right. Or actually, there's an error. There should be a star in front of this parentheses. Yeah. There should be a star there. Sorry. Casting. All right, this is where you get really into trouble. C++ is incredibly powerful because of casting. Create B on the stack, store 300. Create an integer pointer called A, store the reference of B. Cast A from a, oh man, that is, okay, I gotta fix this. Let me fix this. All right, much better. So B is 300. I do slides differently. A is a pointer to an integer storing the memory location of B. Creating D is going to point to a double. D is on the stack because it's storing the memory location of a double. This is where it gets tricky. Take A, cast it from an integer pointer to a double pointer, and then store that in D. Now, I did it again. Man. All right. A into D. Dereference D, store 3.14159. Yes, this is illegal. What's the value of B? But that's a double, not an integer. What is the value of B? This is completely illegal.
B would be 3.
Yeah, does it like
No,
truncate?
it's not 3.
Doesn't truncate like the decimal point?
Completely illegal. The value of B is undefined. Why? When you take architecture, you'll see why.
Okay.
Integers, and you've done the basic, binary 0, 0, 1, 0, 1. So you know how that's done with B. Doubles are done a little differently. As many sets of integers, 3 sets of integers. Depending on how that's stored, is how those sets of ones and zeros are going to be stored at D to represent 3.14159, and then B will be whatever that happens to be at the time. Since the way doubles are stored is dependent on the architecture of the machine, B can be anything at this point.
Not get to 0.
If you're writing a device driver, there may be a reason for this.
You want a random number?
When you're doing your device driver programming, you know the architecture of the system. So you know exactly what that's going to do. Right now it's undefined because we're not talking about a specific architecture. But if you knew the architecture of the machine, you would know what 3.14159, the bits of that would turn into. And then you know what you could then calculate what B would be.
So would B be like all of those numbers like added together, or would it just be like just all of those numbers in a row?
Man, wow. Oh, man. Excuse me. Okay. When you take computer architecture with this, you'll see how you can calculate what B will be.
Okay.
But right now, know that this is completely legal in C++, not in Java. It's not legal in Java because you can't explicitly make pointers. But it can have an undefined effect. That means if you're doing something like this in your program and it's not working correctly, you may be doing something like this. It's really hard to track. Pointers can be pointers to other things. You can point to functions. You can pass functions to other functions and then have those functions call the other functions. You can have an array of functions as well. And then jump down the array of functions to determine which function you want to call and then call that function. You can point to other pointers, which of course can point to other pointers and other pointers, etc., etc. You can point to arrays, you can point to objects. Lastly, void star is a legal syntax. It means I'm creating a pointer to something.
To anything or?
It's going to be something. Oh yeah, you can point to anything.
Okay.
Void pointer can point to anything. And then later you would cast it to what you want. Man.
Do you need a water break?
No, something's in my throat. All right, your labs. There are 2 labs assigned today. The first one is take your array code that you wrote in the previous lab, wrap it in an object, and there's another 2 functions to add to it. And then your other lab is actually a worksheet. I give you some questions about pointers. It's important you understand how pointers work. So I don't think they're too bad, but let's go ahead and go over those.